Hi guys, hello. We hope you guys can hear us well. We're receiving some information from you that we are able to start. So hi guys, I'm really happy to have you here. As you can see, this is the 22nd Azure Meetup, and my name is Dorota, and I'm really happy to have you guys here and to be hosting this event today. Now, obviously, because of some COVID restrictions, we are not able to meet you guys live and in person, but this way we can meet so many people from all around the world online, which we are really glad to have you guys and really happy that our community grows. Now, our headquarters are located in Poland, but most of our community today is located all around the world, so we are happy to actually host this event in English, and this will also apply to our Q&A section, which I will also tell you about in a few moments. But please, if you have any questions, you can also ask them in Polish. We'll try to translate them to English, but both me and our speaker today, Grzegorz Hejman, will be speaking English. Now here we have a warm welcome from our community leader, Paweł Niewędłowski, who also invites you to contact him if you have any questions, if you have anything you want to share, if you want to share your knowledge in our community and maybe host one of the events as a speaker. Please be sure to contact Paweł at współpraca. You can see it on your screen at azuronet.com. Please be sure to let us know about your thoughts about our events. Also, as you can see, the range of topics that we discuss is pretty wide. So this is also the reason to join our community and stay in touch with us. And we are also hosting an event called Expert Summit, the last edition, Expert Summit 2020, was in November 2020, and it gathered more than 3,000 participants. We also are really proud to be a community that gathers 1,425 specialists and experts. Please be sure to join us at meetup.com, where we also gather a strong community. Now here you have some photos of how our events look when we meet live and in person. Right now we're not able to host such events, but we are hoping that it all comes back one day and we'll be able to meet you guys live and catch up. Until then, we are happy to have you here. Some trophies, some prizes, and also a lot of very valuable knowledge, sometimes presented in a more formal way, and sometimes, as you can see, with a disco ball. We are happy to have our main sponsor today, which is EQ Tech. Thank you so much for supporting us, and we are also happy to say that they are having a great job offers, so please be sure to check out their website for more information. Now about our speaker today, Grzegorz Hejman, and the story of a template. Grzegorz is an IT expert interested in all aspects of private and public cloud infrastructure build, migrations, and maintenance. Experienced technical architect, project manager, and infrastructure engineer, he worked for companies like UPM, HCL, Atos, Meetup Cloud, and Ecutech, also delivering successful IT projects. Now we encourage all of the participants to ask questions for our speaker. If there's anything particularly interesting for you guys, or maybe particularly concerning in the topic that our speaker will talk about today, please be sure to submit your questions in the comments down below, and we will try to ask all of them to our speaker during the Q&A section after he finishes his presentation. Our community is also obviously supported by our partner, which is Microsoft. Now, when should you expect another online event? For example, this is our next event that is called Azure Summit 2021, and it will take place, as you can see, on May 13th this year. The event is actually free, so if you want to participate in it, please visit our site that you can see down on the screen. Now, I will leave you with Grzegorz Heyman, who will tell you the story of a template. Grzegorz, do we hear Grzegorz? Let me see.
Hear me now?
Yeah, we can hear you. Hello,
Okay,
Grzegorz.
perfect. Hello.
Great to have you here. Hi.
Thank you for having me. I'm very excited that I can deliver this presentation. So let me just share my screen. And please let me know once it's visible.
Yeah, we're trying to add you to stream right now.
Okay.
Yeah, we see it.
All right, perfect. So I would like to start with a short introduction to EQTech and then say a few words about myself, and then we'll move on to the technical part. So let me say, let's start with the EQTech presentation or a few words about it. So EQTech is part of the Equinity Group, which is the Client Application Development Center, and there are a couple of different teams working there. So, for example, we have technology teams across infrastructure, architecture, and security areas. We support EQ business divisions across the world and the customers as well, external customers. EQTech is still quite new on the Krakow market, but already employ 200 employees at the moment and still growing, so constantly looking for talented people. If you're interested in looking for some information about the open roles or some other information about the company, I encourage you to go to the company LinkedIn profile where you can find all the information. Now let me say a few words about myself. So as already been told, actually I have quite a lot of experience in IT infrastructure field. I've been working IT infrastructure for many years. I've been working in different roles like infrastructure engineering roles, technical project management roles, architectural roles. And my interest mainly lies within the private and public cloud projects at the moment. So I'm not only interested in the technical parts of delivering those projects, but also in the broader topic of like project management and some governance of the processes within the public cloud, private cloud, and generally infrastructure, IT infrastructure as such. I'm also a recovering IT certification junkie, so I collected during the years in IT, I collected over 40 certification. But this year I made myself a promise, which was actually a New Year's resolution that I won't be doing anymore this year at least. So I'll be concentrating on keeping them up to date. So there are like, I guess 8 or 9 which are expiring this year. So I'll concentrate on that when it comes to the learning part of my life. And actually you can see the picture of me delivering a training session to 3 very young engineers, which also happen to be my sons, age 1 to 2.5. So they occupy most of my so-called free time nowadays, and I don't have any other free time for any other things to like hobbies or something. So they are on hold at the moment, but I hope I'll get some free time soon once they are a bit bigger. Older. So, okay, let me move on to the technical part of the presentation. So I'll start with, before I try to answer this grand question, why infrastructure as code, I'll try to define what is infrastructure as code so that we are speaking or understanding this in the same way. And then I will show you a few of the scenarios or use cases that I saw during the project development and delivery of different use cases for during delivery of different projects. So I'll speak about what kind of approaches you can take when you are delivering the projects using infrastructure as code approach. Then I'll talk 2 topics about the modularization of ARM templates and what I call test-driven ARM templates. And those are related, and they actually allow you to create your definition of your infrastructure in a way that is flexible and reusable and that allows you to build those larger infrastructures so that they are manageable and also easy to deliver. Then I will talk about a huge topic, which is testing and security as well. Of course, I won't be able to cover everything there, but at least I think I'll be able to, show you a few areas of concern. So something that you need to consider when you are trying to implement this infrastructure as code approach to your delivering your infrastructure and managing infrastructure. And then we'll have also some fun parts. So we'll have a live demo where we'll try to deploy the infrastructure that is defined in code. I will show you around and we'll see what kind of code we already created and how we can deliver it so that we can build the environment based on that code. Okay, so starting with the first slide. So what is infrastructure as code? And this is actually a quote from Wikipedia, which is a quote from Amazon Web Services in Action book. So let me read it because I guess it captures the essence of the infrastructure as code approach really well. So the infrastructure as code is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. And I allowed myself to highlight one of the words here, managing, because what I saw in the past is that people tend to concentrate on this provisioning part and don't put enough, I would say, consideration into the how the environment will be managed after it's deployed. And this is very important because the management of if you want to manage the infrastructure as code, then it actually it touches on many aspects of the organization that you're working for and your team, the processes that you're using, especially the ITSM processes like change management, incident management, release management, or other processes. So it's very important to put some thought before you start implementing and developing your code, so that you not only develop the code, but also try to create the processes that will be used to managing the infrastructure which is deployed with that code. So now that I guess we all understand and have this common terminology established, let's go to the question, why infrastructure as code? And I try to list here some of the benefits of the using infrastructure as code. Of course, the list is not complete. There are many more. There are some drawbacks, but I try to concentrate on the positive side here. So the first one is consistency. So of course, if you are defining your infrastructure as code, then the whole idea is that you can reuse it then, and every time you deploy it, there's a pretty good chance that you will get the same outcome, which might not be the case when you are doing this manually. So even if you have a very specific definition, I'm sure you'll encounter it in the past projects that when you deploy something manually, it tends to differ from between different deployments. So people may be doing it, different people may be doing things in a different way. People tend to make mistakes. So if you are defining the infrastructure as code, there's a pretty good chance that it will be consistent. Then reusability. So actually, again, the point of defining your infrastructure as code is that you will be using it multiple times. There is no benefit if you define the infrastructure and then use it just once. So that's the main point of having it defined as a code. And improve testability. Actually, when you start to using code to define your infrastructure, it opens a few of the possibilities that you didn't have when you just was doing deployments or management of the infrastructure manually. So when you have the development, the definition of the infrastructure in code, then you can use some automatic tools to test both the code that you are using to deploy the infrastructure and then compare it with the infrastructure that was really deployed. So you can have traceability and also you can have some confirmation that what you are deploying is really what you intended. And I'll show you a few examples later on when I'll be talking about the testing of infrastructure as code, and I have also some examples during the demo. Then the next thing is the speed of deployment. Of course, the automatic way of deploying things is faster, but then you have this trade-off that you have to put more effort into developing of your infrastructure, developing of your definition files. But again, this is the idea here is that you will be reusing those pieces of code. So when it comes to the deployment, it's much faster, but you have to put more effort into it. And then it can help to prevent configuration drift. So configuration drift, what is it? It's when you deploy your infrastructure and it's running for some time and you're actually maintaining it, it's actually tend to take the life of its own. Like, for example, if you deploy multiple servers in your environment and start doing changes on them, then more often than not, you will end up in a situation that each of those servers, even they are in the same category, let's say, have different configuration, and then it actually makes the maintenance of the servers very difficult. Not only servers, but generally the infrastructure difficult, because if there is, for example, some kind of issue with the infrastructure, it's difficult to compare it, all the pieces of the infrastructure to one another, because they differ in configuration. And I specifically say here it can help, but it cannot prevent it, because the configuration drift, this is actually more related to the process side of deploying or developing the infrastructure or delivering the infrastructure and then managing the infrastructure. So it can help, but certainly cannot prevent it. So we'll have to think very carefully about the processes that you develop to make the configuration stable. And one example how infrastructure as code can help is, for example, if you limit the access to the environment so that the changes can be introduced only through the code, then you can guarantee that the change process is followed, and you have the documentation of all the changes that were introduced into the environment. But the flip side of this is that you still have to provide some kind of access to the environment, to the teams that support the environment, the infrastructure. In case of some issues, you don't want to be in the situation where the team starts to, changing the code and trying to deploy it when there is some incident or some major incident. So you want the team to be able to resolve the incident as quickly as possible, while still keeping this configuration under control. So again, this is more about the processes and how you develop the processes, the access to the environment, but definitely infrastructure as code approach can help in that area. And the last thing is that it promotes the following the process, what I called design before implementation. And you may think, well, that's always the case. You have to design something before you build it, before you implement it. But I've seen in my past experience, there were many times that was the case, that somebody started implementing something and then it grows like organically, and it was out of control. With infrastructure as code, it actually prevents it in a way that when you define something as a code, then there are some mandatory values for the resources that you want to deploy that you have to specify, and to know the values for those parameters or those properties of the piece of infrastructure, you have to put some thought before you actually implement it. So you have to think what the infrastructure would look like before you actually implement it. And of course, you won't get every specific detail of that straight from the beginning, because especially when you are building a large infrastructure for the large enterprises, then you have to prepare for that, that the infrastructure will change and evolve. And sometimes you don't even know what kind of workloads will be hosted on the infrastructure that you build. So you have to be flexible in that regard. But generally, when you develop or deploy the core infrastructure, then you have to have the design before you can implement it. So that's what I mean by that. But those are just a few of the benefits that you get when you are approaching infrastructure or using this infrastructure as code approach. But the real question is actually, how will that help you in your specific case? Because the people are using infrastructure as code for many different reasons, and to actually address many different problems. And I actually listed here 3 of the approaches that I saw, actually 3 categories of approaches to infrastructure as code, going from a very specific to very generic. What I mean by that is that the approach on the left, actually it utilizes the definitions of the infrastructure for this very specific approach. It specifies the infrastructure elements which are not very flexible, so you cannot reuse them. It defines the infrastructure as it is, while the approach on the right, this is a more generic, more flexible approach to the defining the infrastructure. So the first one is this backup, what I call backup approach, or configuration backup approach. It means that it defines the infrastructure as it is at the moment in your environment, probably specifying all the values for the properties of your infrastructure without any parameters being exposed, or very little parameters, very little flexibility on that part. And it's mainly, you can use it as a kind of configuration backup. People sometimes use it as a very simple disaster recovery approach, where you can recreate the existing resources if there is anything happening to them. So if they are deleted by mistake, or there are some kind of bigger issues with the infrastructure, you can try to recreate them using the existing configuration that you have. In Azure world, they are very easy to create, so you can try to export your resource definition in ARM template, and then probably clean it up a bit, do some polishing on it, and then you can reuse it. You can use it to deploy the same kind of infrastructure that you exported it from. It can be used also. I saw people were using it during the change implementation. So before implementing any changes, you just export the configuration. If everything is okay after the performing the change, then you can just destroy it. If there is some issue with that, you can roll it back to the existing configuration that you exported, and it's a valid use case. Although it's, as I said, this kind of approach is very limited to this. Actually, you don't have to redeploy the same resources. You can create also in this way a new resources, but then this is not very flexible. You don't have so much flexibility in the way that you deploy the resources. Then this next one is the solution provider approach, which means that the definition files of the infrastructure define some fixed solution. It can be configured in some way. So, for example, you can provide some parameters to specify scale of the infrastructure. So if it uses virtual machines, you can specify parameters that configures how many virtual machines are being deployed, what SKUs are used. Generally, there are maybe some optional components that the customer can configure with the solution, but generally it describes just one single solution, which has a fixed structure. And you can see this kind of approach, for example, for the solution providers that provide the ARM templates on GitHub or in any other repository. So one example is the RStudio Cloud Tools. So when you go to GitHub repository of RStudio Cloud Tools, you will see ARM templates which can be used to deploy the RStudio professional products to cloud environments. So again, this is has a bit better reusability, but still this describes a very specific use case for one solution. And then to the right, we have what I call the enterprise infrastructure approach. So it means that it focuses heavily on providing the modules, actually providing infrastructure that is modular, that you can reuse. You can create different environments using those ARM templates or ARM modules, and it requires a significant development effort. But the idea here is that this development effort will pay off later on when you start to building the environments, and you don't have to recreate the modules every time you create new environments or maybe different kind of environments, but you can reuse the code as much as possible, and this is the benefit of using it this way. Well, it also requires integration with the ITSM processes, because of course when you start to not only deploy but manage the infrastructure as code in this enterprise infrastructure approach, you'll want to actually use it also for not only for the deployment but for the management of infrastructure. So your change management processes and request fulfillment processes, they all need to be aligned to this infrastructure as code approach. So now I will focus mostly on this enterprise infrastructure approach to developing and deploying infrastructure elements. So let me focus on how the ways that you can develop the infrastructure, and then some techniques that you can use when you are developing the ARM templates that support this kind of approach. So first thing that you want to do when you are developing this kind of infrastructure is to create generic ARM templates, which will be actually used as a resource modules. You can think of them as the solution building blocks, and you will be then building the solutions based on those blocks. Then you would define your environment as you'll use one template to define your environment and reference the resources that you want to deploy from those modules. So there are two approaches to that. First is to use the nested templates, and the second one is to use the linked templates. The first one is actually can be used in a bit limited way because there are some limitations on the size of the template that you can build, and it's not very modular because you have to embed the code in one template. So when you are building this enterprise scale environments, it's best to use the linked templates, so that you define in the main template, you define the structure of your infra, and then you references other modules from that template. Once you have this environment defined in a linked template, then you have to think about how you will deploy actually to your Azure subscriptions or management groups. And there are like two approaches at the moment. I'll start with the second one. So the public, you'll have to how the ARM template or ARM service works is when you are deploying the main template, it's embedded in the request to the ARM service. So it can be hosted in some private location, but the modules that are referenced within the linked template, they have to be publicly available. And actually what I mean by publicly available, it's not that everyone should have access there, but the ARM service will have to be able to fetch them during the deployment. So you can secure them in some ways, and the Microsoft recommended way, or the way that usually it's done, is that during your deployment process, you create the storage account, then you create the container within the storage account, you copy the modules into that storage account, and then create shared access signature, which is then injected into the ARM module. I'll show this in the demo section, how it's done. Generally, it sounds a bit complicated, but generally, well, it's quite easy, and you can automate it all, so you don't have to do any manual things when you deploy it. So that's first option, or that's the traditional option when you want to deploy linked templates. And then the second option is actually it's a new one. It's to use template specs. It's in preview at the moment, but the idea here is that the template, you can upload the templates and the modules into Azure subscription and treat them as an Azure resource. So with all the benefits of having it as an Azure resource, which means that, for example, you can control access to it to different users with ABAC roles, and actually you can version control them in Azure as well. But this is, I think this is, well, it's okay. It's a good idea, and I'm looking into when it will be generally available to see if this approach changes or will stay as it is. But one thing that I see as a small issue here is when you are keeping your infrastructure definition in a source control version system like Git, and then you are also uploading them as a template specs and version control them there, so then you have like two sources of your templates that you have to keep in sync. It might be not a big deal because you can again automate it, but still it's from the conceptual point of view, it's not a perfect solution, but again, it might be something. I guess Microsoft will promote it, and once it's out of preview, that might be a very viable option to deploy linked templates. Then one thing that needs to be considered as well here is when you are using this big linked template files that defines the whole infrastructure, the question is how you define how you define the parameters for this file. So will you use one file with one big file with all the parameters, or will you want to use multiple files that define the individual deployments from the linked template? And there is no good answer here. One thing to consider is that there is a limit on the parameters file, which is actually, I think, 64K at the moment, 64 kilobytes. So if you are reaching this kind of scale of infrastructure that you are reaching this limit, then you have no choice. You have to use multiple files. But if you are below that, then you have to consider there are pros and cons to each approach, and I'll talk about it a bit more when we go to the demo section of the presentation. So let's go to the next one. And actually here I listed a couple of different techniques that you can use when you are developing these reusable modules that define the pieces of infrastructure. And again, it'll make more sense when I start to show you how it's implemented in the code. But the general idea here is to try to minimize the need of ARM template customization. So you have to think before how you will create your modules or you structure your modules so that they can be reusable. So probably exposing a lot of parameters and using the other techniques here, like I call them advanced ARM templates. Well, I don't know if they are that advanced, but anyway, it's not something that you see every day what people are doing. So first thing is conditional resources and properties deployment. So based on the parameters from your parameter files, you can deploy some resources or create some properties of the resources depending on the definition of your environment. Then thing that might be a bit more advanced is the self-modifying templates. So you can use the template functions such as JSON that will create a pieces of your ARM template on the fly depending on the parameters, and this is very useful to create actually those parameter-driven templates. So it means that you don't modify once you create the parameter. The ARM template. You don't modify it. You just modify the parameter file, and the ARM templates behaves in a different way depending on which parameters you specify. Then the next thing is the resource or property loops. So you can create, again, if you have a definition of a module that can take multiple parameters or multiple instances of some parameters, then you probably want to create loops that iterate over them and create variable number of resources or properties. And then the last thing is the usage of arrays and object as type parameters. So as I said, there are some limits on the ARM templates and parameter files, and there is a limit of how many parameters you can actually specify for one template. So if you are using this one big linked template that will create the whole infrastructure, you might hit the limit. I guess it's 256 at the moment or something like that, parameters that you can actually forward to the ARM template. So the way around it is to create just the objects with specific parameter values inside. That way you can actually limit the number of parameters that you provide to your ARM templates. And this is also something that I will show you during the demo. This way of delivering or developing modules, of course, requires much more effort than creating simple modules. But again, this will pay off afterwards when you start to define your environment and infrastructure. The modules are much more flexible and usable in different situations. So you can define them. You can define the infrastructure based on those modules and provide different versions of your environment, different tiers, or completely different environments using the same modules. Right, so let's move to the again, interesting topic, but a big one, testing. And actually, the question first is why test? And this is not a rhetorical question. You should really think of what kind of errors, mistakes, or other issues you want to catch and when during the deployment or before the deployment, and then you can try to map the tools that are available for you to catch those errors. So I listed again a few of the issues that you can check during the deployment or before the deployment of your templates. So the first thing is the best practices. Microsoft provides some best practices in developing ARM modules or ARM templates, and there is a document in the documentation, but they also provide a PowerShell module that you can use. It's called ARM TTK or ARM Test Toolkit. What it does is actually it analyzes, it's a static analysis of your code. So it analyzes your ARM template and see if you are following the best practices as described in the document, in the documentation, and then gives you some warnings. You can run it as a step, in your deployment pipeline. You can create a separate pipeline just to test against best practices. So for example, we are using it in one of the projects as a validation step in the pull request validation pipeline. So whenever somebody is doing pull request to the main branch of the repository, this test runs so that we are sure that the main branch is always clear and always follows the best practices from Microsoft. Then the next thing is the syntax errors. And this is actually, it validates if the template is valid or not. So it's quite easy to catch, even with the tools like Visual Studio Code. It gives you some hints if your syntax is correct, but also the deployment process will fail if it's not valid. One thing here to keep in mind is that you can get some false positives, especially when you are using these advanced techniques to develop the ARM templates, because the validation engine is not perfect, so it will show you some warnings or errors, but the infrastructure deploys, so it's a false positive in that regard. Next thing, logical errors. So this is actually to validate that the template deploys what is intended, so what you specified in the parameters file or as a direct parameter, and this one is actually difficult to test before deployment. So the approach generally is to deploy it maybe to some sandbox environment or some test environment, and then check the existing the infrastructure that was deployed against the parameters that were provided to the ARM template. This validates that the logic you use in your template is correct, and you can use, for example, a PEST framework for doing those kinds of tests. And again, I'll show you in the demo how it can be done. And next kind of errors, this is the integration errors. So there are like two categories here. The mandatory dependencies of the resources. So some resources will depend on the other resources. And again, during the deployment process, it's easy to catch because the deployment will fail if the dependencies are not specified correctly. But then there is another part to it, that the order of deployment has to be logical, in that sense that some resources, for example, you can override some configuration of the resources with deploying other resources. And the example here is when you create a storage account and you create the lifecycle management policy, with ARM template, you can deploy only the default one. And if there is any policy before the deployment of that policy, then it will be overwritten. And this is the case, for example, when you are creating network security groups flow logs and you specify the diagnostic settings in them, then they are actually creating this management policies in the storage account that you are storing the logs in. And then if you deploy it in the wrong order, so if you deploy your own policy, it will override the existing policies, and well, you won't see any errors because it's a logical error. It's not a mandatory dependency on the resources. So you have to be very careful when you are doing this kind of deployment. And then there is the next group, which is human errors. So first thing, parameters are not valid. And again, if they are not valid, then probably it can be detected during the deployment or pre-deployment. You can try to use test deployment or use the PowerShell commandlets like test AZ group deployment and those kind of things, or you can just try run the test deployments in your sandbox environment, and you'll see that the validation fails. But the other thing is with human error in this category is when parameters are wrong but valid. What it means wrong? It means that they don't make sense from the logical perspective or business logic perspective. So one example is when you have a specification for a virtual network and you have the address space defined there, and you make an error and put something, the wrong numbers into the your parameter file. Then if the numbers are correct, it means if they are correct IP address or IP range, then they will the template will be deployed, but you'll have wrong values there because well, you made an error. And the problem here is, how do you catch this? Because there are no automatic ways how you can handle this kind of errors. And the best option, or one of the options, is to just use peer reviews and then traditional change management or change control, where people will review the code that will be deployed, review the differences in the code from the previous versions. And there's really no other way, because you have to have some kind of source of truth in this situation. So you have to have some valid input and into your code. So usually it's some kind of design document. And if you made a mistake by translating this design document into the parameters for your ARM templates, then there is no way really to catch it except for somebody else looking into it and checking it. And the last thing about testing is that the software and infrastructure testing, there are different things, and sometimes it's difficult to explain it to people, especially coming from the development or software development background. And I can give you just one example with unit tests. So unit tests generally in software, it's very well described term, and everyone knows how it works, but there are some aspects of unit testing that are not necessarily the same in infrastructure testing. So first thing, the unit tests, usually in software development, they work quite fast, and you have to perform them, or you perform them in the isolated environment, probably even on the developers' workstations, and they are using this isolated environment. So if you have any external dependencies, you can mock them with the code, and actually they cover a majority of the code base. With infrastructure, almost all of those aspects are completely different. So it's very difficult to test your infrastructure in isolation. So let's say you have a resource that requires some other resources to be deployed beforehand, like Redis cache, let's say, and you want to integrate it with the VNet. So you'll have to create some, because you cannot mock infrastructure. You have to deploy it first before you deploy Redis cache and do your checks, automatic checks on it. So you have to deploy the virtual network, to deploy network security groups. If you are logging all of your actions to a storage account, you'll have to create a storage account. So you have to create this whole bubble around the piece of infrastructure that you want to test. And first, it takes a lot of time. So deployment of Redis is around 12 to 15 minutes. It depends, but it's something around this figure. So if you want to really run those tests as unit tests, so you'll have to deploy this Redis cache every time you make any changes to your code, and it's very time consuming. Also, of course, the cost raises. And if you have multiple people working in your team on the same piece of infrastructure or on the infrastructure's code as a whole, then you'll have to provide them with a environment where they can test it, because they cannot obviously test it on their own workstation, because they have to deploy it somewhere. So you have to provide them with the subscriptions to test. And then there are a lot of other issues if they start to test the same modules and use the resources that require unique names. Then they are using the same parameter files with the same names, then there will be conflicts. Generally, it's quite difficult. And the point here is that testing is, of course, very important, but you'll have to put some thoughts into it and develop a process that will catch the errors that you expect that can arrive. And you cannot have this one-to-one, relationship or comparison to the software development software testing. There are differences. All right. Having said that, let's go to the another huge topic, which is security. And the security, this is not specific to infrastructure as code, actually, but you should think really about on security as an aspect of every step that is taken during the deployment, development, and maintenance of the infrastructure. And infrastructure as code is no exception here. But there are some noticeable changes or some important changes that will happen once you switch from this traditional way of managing your infrastructure to this to managing it or deploying it as code. So the first thing, which doesn't exist actually in your traditional infrastructure, is the code repository, and all things related to access to this code repository and the structure of the code repository. So for example, if you have multiple teams responsible for different areas of the infrastructure, then you have to structure your code repository in a different way than if you have one central team that manages it. Then the question of branching strategy. So what kind of branching strategy you choose will have impact on, for example, the deployment process. So how will you deploy your infrastructure based on that branching strategy? Again, how will you guarantee that if you are, for example, using trunk-based development, how you guarantee that the trunk branch is secure, safe, and always in a state that you can deploy code from it? So those are very important things to consider when you are making this switch. Then the next thing is the deployment tools. So the security features of the deployment tools can help you in actually securing the access to the environment, because the whole access to your IT environment will change on that premise that you will be using only code to deploy anything into that infrastructure. So now you have to check what kind of security features the tool provides that will allow you to secure that environment and the deployment process as a whole. So again, if you have multiple teams working on the same infrastructure and responsible for different parts of the infrastructure, or maybe you have the central team that is responsible for infrastructure, but then you have a development team which is responsible for the application. So how they interact, that the development team has the right access to the pieces of your infrastructure that is controlled by the another team. So the segregation of duties and separations of concerns is very important in this approach, and I'll show you just a few tools that are accessible in Azure DevOps that you can utilize to make sure that this access to your infrastructure is controlled and done in a secure way. So we are actually, I finished with the presentation, so now I'll go to the demo. So let's first describe what the demo will look like. So we'll try to deploy a 3-tier environment, dev, test, in production, in a hub and spoke architecture. So it means that there will be separate subscriptions for hubs and 2 spokes, and also separate networks. When I was preparing this demo, I made a decision that I will concentrate on the networking part because it's quick to deploy, and we can have at least 2 or 3 passes of the deployment during the presentation to see what it looked like. We'll use this enterprise infrastructure approach. This is, of course, my term. This is not any official term, but I use it to describe this kind of approach to infrastructure as code. The assumption is that there is just one support team for core infra, so there will be just one repository. We'll use one simple pipeline with one linked templates that define the whole infrastructure, and then we'll have separate per tier parameters file that will be fed into the ARM template to create those environments. And we also have separate pipelines per environment or per tier that use one pipeline template, and I'll show you how to do it. When it comes to the security aspects of it, we'll have in Azure infrastructure, in Azure environment, we'll have a separate management groups per tier, so the subscriptions will be assigned to the management groups. This allows you to provide better management capabilities. So for example, if you want to deploy the policies on the management group level, you can do it. You can also will have a separate service connections at the management group level. So by doing that, you can guarantee that your pipeline can deploy resources across different subscriptions which are part of this management group. So that's very convenient. But again, this is when you're doing this kind of thing, you have to remember about the security implications of that. Now that the pipeline is have access to a larger portion of your infrastructure, so you will have to make sure that it's secured and the service connection is secured in some way, so unauthorized people don't have access to it, or the people who should not have access there don't have access. Then I'll show you how to implement the service connection checks and approvals. That's the security feature of Azure DevOps that you can use to secure it. And I will tell you why you should do it, or you can do it on the connection level, not on the other levels. Then I'll show you how to use the secure pipeline variables. We don't have actually secrets in this demo, but for example, this subscription IDs, they are considered as a sensitive data, so they are not. People usually tend to not include them in the definition of the infrastructure. So not in the ARM templates, not in the parameter files, but use them from some secure, store them in some secure location. And then when it comes to testing, we'll use ARM test toolkit for static code analysis. I'll show you what if deployment and what kind of issues it has at the moment. It's out of preview, but it's still, we'll see what it looks like, and is it really ready, production ready at this moment. And we'll run some post-deployment tests with Pester. So let me switch to the DevOps project that I set up here for this meetup. I hope you can still see my screen, and let me show you through the structure of the repository that we have here. So as you can see, we have 4 folders here. First one is the ARM folder, where we have the environments definition with one main template, which is the hub and spoke template, and we'll go through it quickly in a moment. And then we have 3 parameters file that define the different tiers of the infrastructure. Then we have a folder with all of the reusable modules defined. So every piece of infrastructure that will be deployed is actually specified here. So that not the configuration, but the definition of the resource is stored here in those files. Those are standard ARM templates that will be used by the main template here. Then we have the pipeline definition, and again we are using YAML pipelines here to store everything in the Azure DevOps repository. So we have deployment pipelines. Those are just the definition of the pipeline that extends the template. So we have one template, main template in this demo, that will be extended by the specific YAML definition files for the pipelines. And then we have one what if. Again, this is extension of the main template. So we are using just one template to provide 3 different environments. And then we are using the same template with a conditional step that will run when we run it through this pipeline. Then we have some scripts. Those are like I would say, plumbing for the pipeline. So we are using the PowerShell scripts to copy the templates to the storage account and create the shared access signature that I was talking about before, that is required for the ARM service to deploy the linked templates. Then we are having a script which deletes the templates after the deployment so that we don't leave it afterwards. And the shared access signature is also time limited, so it won't work after some certain amount of time. And then we have the execute pester tests PowerShell. So this will execute those tests which are defined here, and based on the input parameters in the pipeline. So the pipelines that deploy the infrastructure in dev environment will run this test and so on. So let's go through the hub and spoke. So this is the main template. Let me make sure you see a bit more here. I hope you can see it clearly. Sorry, this is the okay. So I can't control my screen apparently, but now it should be okay. All right, so this is a standard ARM template which starts with the definition of the parameters, and those parameters with the beginning with the underscore, they will be injected by the pipeline. So they don't have value here, and they don't have value in the parameter file, but they will be injected dynamically when you deploy the pipeline. So the first one specifies the location of the artifacts, meaning the ARM modules that will be referenced later on by the deployments. The second one provides the SAS token, so it's the shared access signature token that's required so that the ARM service have access to those modules. And then we have three parameters which actually specify the the ID of the subscription. Hub subscription spoke and the second spoke. They are all defined as secure strings. So Microsoft says they are when something is defined as a secure string, they are making effort not to expose it in, for example, deployment logs or anything like that. So you are you can be pretty much sure that those secrets will not leak, even though, as I said, we don't consider subscription ID as a secret, but still don't want to store it in a repository. And then we see the parameters for different infrastructure elements, and this is one of those instances where we see where we use object as the type of the parameter to limit the number of parameters that we want to forward to this template. So as you see, the whole network is defined just with one parameter, which has the type of object. So it's basically a JSON object that defines the network, and we'll see in a moment what it looks like in the parameters file. Then we don't have any custom functions, but we have variables. So we define the location of the modules that we'll be referencing in the resource section. Here, it constructs the URL or URI of the module template file so that the Azure Resource Manager service can access it. And as you can see, it dynamically gets the location from the artifacts location parameter, and then this shared access signature token is appended to this. So this way, the Azure Resource Manager service can access it without any, securely, without needing any kind of logging or something like that, because it's actually you cannot use any other security measures other than embedding something in the URI of the resource you are referencing. So here we have the references to all of the modules that we'll be using. And the two additional variables, those are for the log workspace ID. So this is the workspace that we'll be using for logging. So this is one of the first resources that we'll be deploying. So we want to log all activities in our subscriptions to that log analytics workspace, and the storage account that will be used as well for keeping the logs for an extended period of time. So again, a cost thing, it's cheaper to keep it in the storage account than the log workspace. And because they will be used almost by all of the resources, because we want to log everything, then it makes sense to define the ID as a variable here in the main template, and then just forward this ID to the other templates. And then we have the resources section, which actually define the only resource type that we are using in the main template, which is the deployment type. So we are using this deployment type to deploy all other pieces of the infrastructure, and it references first, it references the subscription ID, so different pieces of infrastructure will be deployed to different subscriptions. Then the location, and actually in this case, this is deploying the resource group. So it's the deployment template or the deployment reference. The ARM template reference documentation specifies that if you are deploying something on the subscription level, you have to specify the location instead of the resource group. Of course, it makes sense here because we don't have any resource groups yet. We are just creating them here. So we are targeting the subscription and the location here. And you will see some issues with the validation of this template just because of that, because the validation engine in both the Visual Studio Code and the Azure portal is not perfect. So they will say there will be a warning message that if you are specifying subscription ID here in the deployment, you should also specify the resource group ID. Of course, you can't do it here because you don't have this resource group yet. Then in the template link, you will use the variable that defines this specific module, and we have module for resource groups. So this is here. And then the parameters, we are forwarding the parameters that we get from the main template parameter logging. It's defined here, and the parameters are specified in one parameters file. And this actually continues. So this file is quite long, but you can see that it's actually mostly copy and paste. So you can copy and paste this portion of the file and just specify different parameters or different resource types. Like, for example, we are deploying storage account management policies, and we have to forward specific parameters for this module. And then we are also starting to create the dependency of the deployment. So, for example, this one depends on the storage account being deployed. So, of course, before creating the management policies, we have to have the storage account. So this is where you define the dependencies. But generally, this is very simple, although it can be quite long. But the whole beauty of this approach is that once you develop your modules and you can reuse them in many different situations, the creation of your environment is very easy. It's almost like building it from the existing building blocks. Actually, it is exactly this kind of approach. So once you have the modules, the most important thing is to create the modules right. And of course, you can't do it the first time you do it. It won't be perfect, and you'll be refining them. But if you put some effort into defining the modules in the right way that actually support your infrastructure, then creating the infrastructure is very easy. So that's basically it when it comes to this main template. There's nothing more here. So let's look maybe on the parameters file and what it looks like for the dev environment. So you will see that we have some placeholders, empty values here for the parameters that will be injected in during the deployment of the template. We have the resource group names, locations. This is all something that the modules expect to have when you deploy the infrastructure, and this goes for all of the resources. So for the log workspace, log analytics workspace, storage accounts, and so on. So we are defining specific values for the parameters which were exposed in the modules. So we have the definition of the whole virtual network here, and the modules are developed in a way that if you want, for example, to add additional subnets here, you don't have to modify the module. You're just modifying this parameter file. So again, copy paste this kind of setup and just specify the right values here. So this is what the parameter file looked like. And let me just go quickly through one of the modules, or maybe two, which is to show you those what I call advanced techniques when you are creating the templates. So what kind of techniques you can use for creation of this. And this is actually creating network security groups. And it's a good example because we have a couple of different things to talk about. First of all, you can see that the resources created here, we use this copy functionality. So we'll create multiple copies of network security groups based on the parameters we specify in the parameter file. So in this example, we are creating subnets, network security groups based on the number of subnets. So the idea is that we'll create separate network security group per each subnet, but then there is also a condition here. So we are not creating security groups for gateway subnet, or it should be Azure firewall subnet as well. So those subnets actually don't support network security group. You cannot assign network security group to gateway subnet. So it means that we won't deploy them, so they won't be created. Here the name is also constructed dynamically based on the parameters files and the copy index, which will increase every time the loop evaluates. And then we have additional copy, which actually creates security rules within the network security group. So people ask, can you have nested loops with ARM templates? And actually it depends, because you can see here we have the loop that goes over the resources, which controls how many resources we are deploying. And here we have additional loop that goes over the properties of individual resource. So it's really not nested in that sense that those loops are different. But then if you want to, for example, if you have some resource that will have a nested loop here, again, it won't work because you cannot nest loops of the same types. So basically that's how it works. And maybe I'll show just one more example of some, because I have something here that I want to show you. And this is actually generating, no, not this one. 1 second. Yeah, this is when we create a network or virtual network and create subnets, we are also associating network security groups and service endpoints and private endpoint network policies, those kind of things. So based on the subnet, we also want to assign specific network security group to it. And again, the situation is that for the gateway subnets, we don't want to do it, but the way the module is created, or the way that the definition of the subnet of virtual network works in Azure is that you cannot have null value here. So we'll have to have this condition using this very elaborate expression, which is actually quite simple, but it just looks not nice because well, the syntax of ARM templates is as it is. But generally, what it does, it compares the parameter value, so it checks if it's a gateway subnet or the Azure firewall subnet, and then it creates the JSON on the fly. So it creates either null, so there's nothing there, or it creates the JSON here with a specific format. So you can see that it's this kind of self-modifying ARM template that I was talking before during the presentation. So it's a bit advanced, and it will fool the validation engine again. So for example, for the tests that will be run against the best practices, Microsoft best practices, it will show you that this parameter that we use here, I don't remember which one is it, but one of them, it will show that it's not used in the template, and it will just break the build. So this is why we need to create this kind of either you will put this in the output of the resource definition, or you will use this this parameter in some other place of the resource definition, just to make sure that it's used somewhere. But generally, this kind of approach is very flexible and very useful when you need to generate the template based on some input parameters. But okay, I see that it takes a bit longer than I thought. So maybe we can go to the pipeline definitions now and to the main pipeline, just to show you the steps, and then we'll go through the deployment and see what it looks like. So this is defined. Actually, I defined the pipeline as a template. So first thing it specifies, it's actually the required parameters that it has. So there are some parameters that we require, which will be environment specific or tier specific. So there will be different parameters for the dev, test, and production state environments. And then we define the stages and of the pipeline. First stage being the static testing of the ARM templates. So we are using this predefined task. This is the Azure DevOps extension. It's free. You can install it in your DevOps organization, or you can actually use PowerShell as well, because actually the tests are delivered as the PowerShell modules. This is just it works. It's free. It's easy to use, so we use it. You specify the template location for the test, so we have every ARM template in this folder, and then you are specifying the results, where the results should be stored in the main template. So the way ARM TTK works is actually it's checking against the best practices defined by Microsoft, and there are different practices based on the if it's the main template or if it's the template that is referenced by the main template. So this is why you have to specify which template is the main template here. And we are not skipping any tests. So when you are doing this kind of deployments for the customers, it's good always to put this, even if this is not required, but they will see that you are not skipping any tests from this test suite, so everything should run. And then we are just publishing the test results to the Azure DevOps environment, so they will be visible there. The next stage is publishing the artifacts. So we are publishing the source code, so the ARM templates to be available to the next stages of the deployment. Again, very simple step, nothing to show here. And then the next stage is actually the deployment of the resources. So we start with the PowerShell script that copies the artifacts to the temporary storage account. So it creates the temporary storage account, creates the shared access signature, copies the file, and then defines those variables that will be injected into the ARM templates as a pipeline variables. The next thing is the what if deployment, and this is controlled by the parameter file. So if you specify in your pipeline this parameter to be true, then this step will run. If not, then it will not run, and will continue with the next one. And the next one is the real deployment of the infrastructure. So here again, there is a condition on the what if parameters, and the previous ones not being cancelled or failed. So if it's not a what if deployment, then it means it's a true deployment of the infrastructure, and we'll run this code. Again, very simple. We are using the ready-to-use task from Azure DevOps, and we are injecting the parameters here in the override parameters. You can see that the generated artifacts, location, store, SAS token, and the others like hub subscription ID, those kind of things are forwarded to the ARM template here. And then the next thing is to run the pester test. Again, we are using PowerShell script, and the script that executes the tests is located here. Again, forwarding some arguments from the pipeline, publishing the test results, and the last step is just to remove the artifacts from the resource group. So actually, we are removing the whole resource group. That's just a security measure to make sure that this storage account with all the module definitions will not stay after we deploy the resources. And this actually has condition which runs always. So no matter if the previous steps are cancelled, failed, or in whichever other state, it will always run. It will always delete that file. So maybe let's go with one of the definitions of the pipelines now. So as you can see, the definition is very simple. It just specifies the name of the pipeline, the trigger, which is none. We are not doing any automatic triggering of those pipelines. And then it extends the main pipeline and provides the parameters to the pipeline. So this is very simple. You can create multiple environments, just modifying the parameters which are here specified here. And then one last piece of code is the test that we are running here. This is a pester test, and you can see it's a very simple one. We are not covering every piece of infrastructure that we are delivering here. I concentrated only on the virtual networks, and actually we are checking the network names, the address space, and the address prefixes of the subnets and the subnet names. But the general idea is very simple. So first you are defining you're getting your deployed infrastructure. So with the PowerShell commandlet, so we are getting the virtual network here with the specific name and within a specific resource group. This is defined. This is why we are defining them based on the environment. So different parameters for different environments, and then we are comparing it with the expected values. So we have the expected values defined here, and then we are creating dynamically the test cases so that we don't have to repeat ourselves. So this is a loop that actually adds the test cases to the collection of the test cases, and then in the context piece of the tests, we are defining the different tests that will be run, and that's basically it. It's very simple. You can use it in also in a different way. So you can actually provide the parameter file of the environment to this pester test, so that you can utilize the parameters which was defined in the parameter file instead of hard coding the values here. But this gives you, I guess, another layer of protection in case that you are doing some kind of typos or something. You have it defined in two places. All right, so let's try to run the pipeline actually and see how it works. So we have the deployment pipeline, test pipeline defined here, And actually, I cheated a bit because I was testing it, so I already ran the development environment pipeline, so to see that if it worked correctly. So let's test it with this one. So this is deploying a infrastructure to the test environment, and we'll just run all of the stages. You can select the stages here, so you can see that this first one is this test ARM template. So it will test the templates against the best practices, then publishing artifacts and deploying resources. We are using all of them, and we'll just start it. And while it's running, we can look at one of some of the security aspects of Azure DevOps that provides some levels of security and how we can use it. So first thing, you have this service use library where you can define your variables, and we are using the variable groups here to provide this subscription IDs to the deployment pipelines, and then we are injecting them in the ARM templates. And you can see that we created the hub subscription ID, spoke 1, spoke 2 subscription ID, and this is based on the environment. So this is the name of this variable group, which is passed to the pipeline template so that it knows where to look for the values. And those values are stored here as a secure values. You can see that there is this padlock icon here, so you can't see it here. And again, Microsoft will try their best not to put the output, these values into the logs of your pipeline runs. There's one more level of security you can get here. So you can link the secrets from the Azure Key Vault as variables here. If you really have some secret values like connection strings to your databases or anything like that, you can actually store them securely in the Azure Key Vault. As I said, because this is not really, the subscription ID is not really a secret, it's just some value that we don't want to see in the repository. In the pipeline runs, we keep it here as a pipeline variable, and it's okay for this kind of use case. But if you need more security, then definitely you can use it here. Then the next thing, let me see if okay, so it's still running. It's already published the artifacts. We'll go through this in a moment, but let's use this time to talk about some other security features. So when you deploy your environment, you always have to specify to which, when you deploy your code or your pipeline, you have to specify which environment you will use. So I already predefined those 3 environments, and the pipelines are targeting those environments. And what I see people sometimes do, they are trying to secure access to the infrastructure based on these environments here. So, for example, what you can do, let's say you select the production environment, and you try to configure approvals and checks, and you can see that there are multiple different things that you can check before the pipeline can use this environment. So you can have approvals, you can have the branch control type of checks, so you can deploy, for example, to this environment only from a specific branch. You can specify business hours, and so on and so on. The problem with this approach is that, okay, if we have those 3 environments defined here, but the pipeline can generate new environments on the fly. So, for example, there's nothing stopping me from going into the repository and changing in the definition of the pipeline, the environment, maybe even creating a new branch if I cannot directly modify the main branch, and then specifying a different environment, let's say a new one or something with any other name. And this environment will be created dynamically and will bypass all of the security features here. So it's not the best option to secure your deployment. So you may ask, why then this feature? What kind of security it provides? And it actually provides security to the resources which are connected to this environment. So you can see that this environment is not only a place where all the pipeline runs are recorded, but you can add resources to this. But the problem is that it's limited now to only Kubernetes namespaces and virtual machines. So if your deployment target is a virtual machine or Kubernetes namespace, then you can use this feature to secure access to it. But we are not accessing any of those resources. We are just accessing the Azure environment based on the service connection that we created. So it won't help us here, and it's very easy to bypass this kind of security measures. So how can you secure access to the environment when you cannot use the environments here? Well, you can try to configure the service connections, which are defined here. So I created 3 separate service connections that are targeted on the management group level. If I click edit, you can see that this is on the management group level development. And then at the moment it grants access to all of the pipelines, but you can just remove this one and specify which pipeline during the deployment you will have to acknowledge that the pipeline have access there. But this is not the most important thing. The most important thing is that you can have exactly the same kind of security checks and approvals that you had with your environments. So for example, we are in development environment, but let's say we'll try to go to the production one, this one, and let's create the approval. Actually, it is already. So I put myself here as the approver. So anytime I want to deploy to the production environment through this service connection, I will have to approve it. There is one advanced setting that says that if the approvers can approve their own runs, of course, I selected it here because I'm only person here using this environment. But if there are multiple people within the team, you can just specify that the person that triggers the pipeline cannot approve actually this service connection. So let's see. Okay, the deployment is running. Actually, it's removing the artifacts at the moment. So it seems that that it ran correctly. So let's see, maybe because well, it just goes through the steps that we defined in the YAML pipeline. But let's see that the results of the test that were run, and I guess it will be available in the test artifacts here. So you can see that there were 285 tests that were passed, nothing failed, and you can see the test results if you select here. And the first test results that you have are the tests against the best practices. No, actually, those are the pested tests. So you can see we were describing and checking the parameters of the virtual networks. So it all goes here, and then you probably somewhere the bottom, yeah, you can see the ARM template toolkit test results. So they are checking against some best practices from Microsoft, like admin username should not be literal, API versions should be recent, those kind of things that are described in Microsoft documentation, and they are put it into the because we are publishing it to the pipeline results, it's visible here. I can see that it's still running, it's still removing the artifacts resource group, but now I guess it will be, now it's completed, so it's successful. So let's try to run one more time, but this time let's try to run the production one and see what happens when we, and I will just remove the first stage, the test ARM template, because it's the same template, so it doesn't make sense to test it again against the best practices. So you can see that this step is skipped and we are going directly to the publish artifacts. And now actually the job is pending for the because we are using the Microsoft host, so we'll have to wait until it's complete. It actually gets any agent. But let me check if I have any previous runs of a what if test pipeline, and I guess I have it here. Yes, it's there. So let me go through the results of the what if deployment to show you actually what kind of output you will get from this kind of deployment. So the idea here is that you are not deploying any infrastructure, you are using just the PowerShell commandlet, which should give you the information about what your ARM template will deploy and will modify. So you can see that it should specify which resources will be deleted, which will be created, which will be modified. There was no change if this sign, and which will be ignored. And the way I run it is I actually, just before this pipeline, I run the pipeline that deployed the infrastructure. So ideally, the result should be that there is nothing modified, nothing created, nothing deleted. everything should be with this status no change. But if we, I won't read all of this, but if we go to the bottom of it and see the summary, you can see that it says that 4 resources will be created, 32 will be modified, only 11 will not change, and 3 will be ignored. And the reason why it's actually having this false positives is, first, it's actually it's described in Microsoft documentation pages that this is not perfect yet. It's been released from preview quite recently. And the second thing is that we are using some of the advanced features of this ARM templates, and one of them maybe not advanced, but we are heavily using the resource ID function of ARM template, which is not compatible with this version of what if. And there are also some other issues. So you can see that at least with this more complicated deployments, the what if is not an option at the moment. I wish Microsoft will improve it. And actually there is a specific project in GitHub where you can report all of this kind of false positives. So if you want to help to improve it, then that would be great. I certainly will be logging some of the issues that I have here there, so that they can work on it and make it usable. Okay, so let's see what's the stage of the production deployment, and we can see that it's waiting here, and you can see it's waiting for the approvals. And because I'm the only approver, I can review it here, and I can approve or reject it, the deployment of this production infrastructure. And this time I will just reject it here. So you can see that you can have this control on how you access your infrastructure based on the service connections that you create, and there are certainly some other security features of Azure DevOps that are very useful, and there is no just one switch to make it secure. You'll have to really check what's available and try to develop your deployment process using the security features of this tool. So, but you can actually secure it pretty well. So it's a good tool to use, and worth checking those security features. And with that, I guess I will end, because we're already running a bit late with the presentation. So thank you very much for this part of this presentation. I hope there was something interesting in it here. If you have any questions, then I'll be happy to answer them now. But if you have any questions that or comments that you don't want to ask now, or want to ask me individually, you can just connect with me on LinkedIn. I'll be happy to answer them and actually have a talk about this presentation. So thank you very much.
Thank you very much, Grzegorz. And we actually have some questions to you. I will try to put them on the screen right now.
Sure.
So this is the first one. Can we make the resource group name variables or other variables dynamically rather than hard coding them?
Yes, of course. This is all actually you can because the deployment of the resource group is created within the Azure template, so you can use all the functions of the Azure template to create the resource group names, or the variables, or whatever. Actually, you don't have to hard code it. It's just hard coded here because the way you are usually doing it is that you get the specification of the environment, and they are specifically defined there. But you can generate them, no problem. Actually, one approach we had in some recent projects for one of the clients was to generate the names of all the resources dynamically with the ARM template, and then use the output of the ARM template as the input for deploying other resources. So the names were generated dynamically based on some input parameters. So definitely you can do it.
Another question from the same viewer. How do you put/upload these variable groups for the first time? Do you do it manually? Or
yeah,
otherwise?
so again, you can create it manually, you can create it, or you can link, for example, as I was showing, the secrets which are stored in the key vault, so that you then, any way you want, put them into the key vault in a secure way, and then provide access to this to the key vault to the Azure DevOps, and then define it there. Actually, it's like mapping them to the key vault values.
Thank you very much. Another question from a Facebook user should be on your screen. Are there alternatives to ARM templates?
Yes, of course. There are multiple technologies that you can use. The most, I guess, common one is Terraform that people use. The thing is that, well, it's there are pros and cons for every tool. No tool is perfect, and sometimes you just have to use specific tool because of some other aspects of or requirements of the project. Also, my approach to using tools from different vendors is to try to minimize the use of external tools. And I considered in Azure environment, I considered Terraform an external tool because it doesn't come from Microsoft. So if I can accomplish something using ARM templates, I prefer to use ARM templates because they are coming from the same vendor, and there are some benefits of using the tools of the vendor. Of course, if you already have some if you invested in other tools like Terraform, you have the team that have the skill set to use Terraform, by all means you can use it, and there's nothing wrong about it. Just it's the selection of tools is a much deeper subject, and then just we can talk here, but there are alternatives to ARM templates, definitely.
Another question is, what are the biggest challenges with using ARM templates?
Well, I think when you are defining these big environments and big infrastructures, you will hit the limits of the size of specifically the parameter file. Especially when you're using this approach, when you are using just one parameter file to define the whole infrastructure, it's a great way to thinking about it, because you have just one place where you define the whole infrastructure. So if you need to do any changes, you are just editing one file. But then if you hit the and you have all the settings in one place, but then when you hit this hard limit on the size of the parameter file, then you have to think about how you split it and how you provide access to specific teams to those different parameters file, how you organize it, how you exchange the values between the deployments. The other thing, I think that we were not talking about, I didn't talk about deletion of the resources, how you delete them. Actually, you can try to use the complete mode of deployment, but it's not really useful with the linked templates. So you will have to devise your own way of deleting the resources. And then there is one thing also that is, for example, when you compare it to Terraform tries to keeps the state file. So it actually understands what was deployed before, and there is no such information in ARM templates. So every ARM template deployment is treated as a separate entity or separate run. You can get away with that when using Azure Blueprints, which is another service. It's again a very interesting thing and a very interesting way of using. You can use ARM templates with blueprints and also some other things like RBAC assignments and policy deployments. But this is another discussion. But so there are ways to overcome the limitations, but there are definitely some challenges.
Another question from Kamil. How about Jenkins pipelines? They are working pretty much the same like DevOps pipelines in your view?
Again, this is I guess the same kind of question, like what tool you use to define the infrastructure. I see some benefits in using the tools of the vendor. So if we are talking about Azure and we have Azure DevOps, then why not use it? If the company invested in Jenkins, you have the Jenkins skill sets in your team, you can pretty much use any tool you like to deploy it. It's just a preference. I guess it's a matter of preference, then it's a matter of the skill set that you have in your teams. The third one, maybe there are some other aspects of the decision making for which tool you use.
And a question from Adam. How to handle names that must be globally unique?
Yeah, so for example, for the storage account, you can generate some part of the name again within the template. The standard way is to generate it based on the resource group that you are deploying your resources to. It's pretty much, it guarantees that it won't repeat anywhere else. I guess that's it. You're just generating it. The good thing about generating it based on the resource group is that it's it's consistent. It means that every time you are running your pipeline, the name will be the same. It's not like, because you can try to generate them, for example, with PowerShell or something, and try to generate the pseudo random names, but then with everyone you come with a different name, which is not what you want really. You want to have unique names, but the names that are repeatable when you're deploying the same resource. So I hope this answered the question.
Thank you very much. And we have another question from Facebook, and I think this is the last one that we have for tonight. It's pretty general, but let me see if I can put it on the screen. This is the one. Don't you think Azure is getting too chaotic?
Well, when you check the Azure documentation, actually, and there is a good set of articles how Microsoft Teams work in this agile era, and how they are using their own tools to actually manage the development of a platform. And when you consider the scale of this whole enterprise and the scale of the project, is it getting too chaotic? When you look at it in that way, that there are multiple different teams working on different pieces of this whole thing called Azure, then of course it might get a bit chaotic, and it might be difficult to understand and manage, especially with this whole platform changing so rapidly. But I guess this is also the case with other services, other public cloud providers, or providers of any services of that scale. So it's difficult to say, actually, to compare those kind of platforms. Is it too chaotic? There are some challenges with using Azure, of course, but there are also challenges with using any other technology. So it is taking into consideration the rapid growth speed and the scale of the project. I'd say it's not that bad.
I hope this answers your question, dear Facebook user. Thank you so much, Grzegorz, for your answers, and also for a great, very helpful presentation that you gave us tonight. We hope that you guys enjoyed it. And there were questions actually during the speech if the stream would be saved. Yes, we are hoping to save this stream and then put it on our web outlets. So please be sure to check our Facebook and also our website. So thank you so much, Grzegorz, for your time and a great presentation. We hope to see you again. Thank you so much.
Sure. Thank you very much. Bye.
Bye-bye. See you guys.